For characteristics of PN junction diode, the diodes are manufactured by silicon and germanium like that. These are the diodes we have. The characteristic of this diode in forward bias and reverse bias and zero bias. How to conduct experiment, how the diodes are constructed. The diodes are constructed by using semiconducting materials like silicon and germanium. Let us take this diode. It has two terminals, positive terminal and negative terminal. The positive terminal indicates as anode and negative terminal indicated as cathode. This is the line which indicated on diode. This line indicates it is a cathode and another terminal is anode. To conduct characteristics of experiment, we have to go for breadboard, and breadboard 1 ammeter, 1 kilo ohm resistance and a PN junction diode and 1 voltmeter. A DC supply is required to conduct this experiment. First we take in breadboard and we connected positive supply here. The positive supply. The breadboard how works, you can see the link in description how the breadboard works. The positive terminal of RPS, it is a RPS, regulated power supply, RPS, and the positive terminal is connected in breadboard. Zoom it. The positive terminal is connected according to this experiment. This is the 1 kilo ohm resistance we have to place. Like this circuit we have to connect 1 kilo ohm and 1 ammeter, 1 diode we have to connect to conduct experiment. And 1 diode we have to take. This is the diode we have to consider to conduct this experiment on breadboard. The characteristics in forward and reverse bias how to conduct. First we are going to conduct forward bias. The positive terminal we connected here. After that, the positive terminal is connected from regulated power supply to 1 ammeter. 1 ammeter, this is the negative terminal of ammeter. This is the negative terminal of ammeter. This is the positive terminal of ammeter. And this is the ammeter we are using to conduct. First we connecting resistance like this. The resistor we connected. Connecting. Diode we placed on breadboard like this. Next, the RPS negative terminal is connected on diode. Like this we connected the regulator. Red color line indicates positive terminal and resistor we connected and diodes are connected. Now we are connecting, resistor is connected to diode. And this is ammeter we are connecting, ammeter 2 terminals. The ammeter 2 terminals are connected to measure the current which flowing through this. Ammeter is connected in series to the diode. Ammeter is connected in series with the diode. The voltmeter we are connecting here. The positive terminal is connected and negative terminal is connected to diode negative terminal, that is cathode. The cathode is connected to this voltmeter like this. Now switch on the supply. When you supply switched on, the 2 voltmeter showing 0.04 volts, that is almost 0 volts, and ammeter showing 0 amps. Now we are conducting experiment by increasing the voltage. The voltage is increased and the voltage is increased 0.2, 0.3 volts. The voltage is increased by increasing the knob. The ammeter shows 0.1 current, milliamps it is. The ammeter is in milliamps. Now it is a RPS, positive terminal is connected to resistor. According to this circuit, forward bias and reverse bias circuit, when positive terminal is connected to diode anode and negative terminal is connected to diode cathode, then it is called as forward bias. The same opposite, quite opposite, when negative terminal is connected to diode anode, it is a reverse bias. Now we are going to conduct experiment on forward bias, how the diode works. Because this voltmeter shows the voltage across diode. The supply voltage is measured here. The supply voltage is measured by the meter. Now you can see here the positive terminal of the RPS, the positive terminal is connected to resistor. After that the negative terminal is connected to this is the negative terminal that is connected to anode cathode of diode. The diode cathode negative terminal is connected, that is forward bias. Anode is made positive with respect to cathode, then it is called forward bias. A resistor is connected. The resistor, another terminal is connected to ammeter. The ammeter positive terminal. Ammeter negative terminal is connected to anode of diode. You can see anode of this, because we are measuring the current through diode, because that ammeter should be connected in series. Next, the voltmeter, it is the voltmeter 0 to 20 volts. It is connected across the diode. You can see here the voltmeter positive terminal is connected to anode and negative terminal is connected to cathode. That is this voltmeter only for diode. This voltage, RPS voltage gives. Now we are increasing the voltage. This shows the voltage across diode. Now we are increasing the voltage by using this. Now we are increasing the voltage. Initially there is a very less current. When there is no voltage, the voltage is current is 0 and voltage across diode also 0. When you increase the voltage, now we are increasing 3 volts, a small current enters. That means the diode conducting in forward bias, 2.5 milliamps is going through diode. When you increase again, the voltage across diode is 0.66, constantly it is maintaining, and we are increasing the voltage. Now the current is also increasing through diode. When you increase the forward bias voltage, the current conducting by the diode increases. That the same thing we are taken in tubular power. In forward bias, input voltage from 0 to 10 volts also you can give forward bias voltage across diode, and the diode conducting current in forward bias, it is showing now 10.7 milliamps. Like that we have to, for different voltages, different currents can flow through diode. That is forward bias. When you reduce the voltage, now we are reducing the voltage, you can observe the ammeter showing, this is the ammeter showing milliamps with less current when you reduce the voltage. When you increase the voltage, it is increasing. The diode characteristics, forward bias, how the characteristics are? The forward bias characteristics are like this. The current should be increased when forward bias, when the voltage applied across the diode increasing, it is constant now. Vf is forward voltage of the diode is constant, it is increasing. That means the diode conducts in positive only, forward bias only. When you made the reverse, the diode will not conduct. It acts as insulator, open switch. When the diode is forward bias condition, it acts as closed switch. Now we are going to change the terminals of the diode, positive to negative, negative to positive. That means it is a reverse bias. When positive is connected to cathode and negative is connected to anode. Now we made as the diode is reversed previously. Now if you apply the voltage also, there is no current flowing in this right hand side ammeter, because the diode does not allow the conduct electricity when it is in reverse bias condition. There is no current in ammeter because the diode is in reverse biased condition. The same thing we have to plot the graph. When you increase the more voltages, then the diode will break down. At that moment, negative current will flow. In reverse bias condition, we can shift now the terminals. We are changing the ammeter because in reverse bias condition, the leakage current is in microamps. You can see we are changing the ammeter. In reverse bias condition, it's the ammeter, the diode allows very less current that is leakage current. In microamps we can measure. Now let us see. Let us switch on the ammeter. Now in reverse bias condition we are increasing the voltage. Now it's showing this ammeter shows leakage current, negative leakage current it shows. This is about